Good morning, Scott here, known as Cantaloupe to some online, and I'm bringing a technical video to you on a subject that's interesting to me. It might be of interest to you or someone you know, and that is a very brief summary of a particular data type. If you're into computer programming like I am, game programming and data structures, there's an interesting type of structure that is useful many times in programming, and it's not something that I think a lot of programmers are aware of necessarily. So I want to go over it real quickly. There's a way to pack data, and if you're into GPU programming, there's graphical processing unit programming. You might be familiar with buffers and strides, where you have vertices or other types of data that are packed into an array style data structure. And buffers are useful because they're very fast and efficient. It's a block of contiguous memory that is uploaded to the GPU, but it doesn't necessarily need to be. And I'm not strictly talking about GPU programming in this video, but the data structure and something that you can do with a flat array in the same sense, actually. So consider that you can have a multi-dimensional array with, like a piece of paper is two-dimensional. You have width and height. The same can be true with a data structure where you have a width of elements and a height of elements. And these can be expressed or accessed, I should say, with separate indices. So you have an array with an array in each element, and then you give it an X and a Y to access the value at that location. And this is common and a very valid way to arrange your data if necessary and if it's helpful. You can actually have higher dimensional data structures, and this is where it gets interesting. You can have, for example, three-dimensional data structures with not just an array in each element, but an array inside each of those arrays, and then it becomes three-dimensional, obviously. So, and then you would need X, Y, and Z, or however you want to describe it, to access the value at that point. And it's analogous to a spatial location, and this is where it gets useful in 3D programming, because typically you're working with three dimensions in graphical programming if you're doing 3D stuff. But here's the idea. The idea isn't necessarily multi-dimensional arrays, but how you can reduce a multi-dimensional array into a flat array and still have it be useful with any number of dimensions from one to whatever. And the way you do that, this is where hopefully the gem of wisdom in this video comes from. It's a way to divide your space inside that flat array with a width, a height, and perhaps a depth, or if space permitting, you could have even a fourth dimension where you might pack an entire video style data structure into an array, or something like an animation that changes over time. And you can divide your width by your height to get your depth. I'm going to rephrase that in just a second here. So you have a width of data, right? And if you're expressing it in a buffer style data structure, it's not going to be obvious just by looking at it, but there can be an implied structure within that flat structure. So your width is, you can have a stride probably where you have, X, Y, and Z repeated for each vertex, for example, just an example. And besides the stride, you can also embed dimensionality, is the point I'm making. So you can have a width, and then at the end of that width, if you needed to access, say, the second row of a two-dimensional array, you would mod your index value by the width to get the row that you're on, even if you're still working with a flat array. Hopefully that makes sense. So then you do the same thing. You divide your width and your height to get what would be a third dimension, still in this flat array. And the whole point here is that it's all implied. It's all in the design of the data, and the data itself is still one-dimensional. The array doesn't necessarily need to have multidimensionality, but you can create an implied structure within that using strategic planning and assigning it a width, a height, and then the final dimension, it turns out, doesn't need to be defined because it is addressable just by iterating through the array using the previous two dimensions, if that makes sense. So you don't necessarily need to know the depth of your three-dimensional array if that's what you're working with, only that it has a set width and height, and then you know beyond that what depth you are at, and you can actually get the depth by using some math to figure it out. But it doesn't need to be predefined, is my point. It can grow and shrink in depth as long as it has the width and height. I don't know if that all makes sense, but I might include actually a graphical representation of this idea to help it be more understandable. That will be probably a part 2. And if you're into graphics programming, it might be interesting. Reach out with questions or comments to whitehotrobot@gmail.com. Thank you.